Hello and welcome back to everyone to the CHPC SCC pre-recorded series. My name is Alan van Dieman and today I'll be presenting on file systems with a focus on Linux and network file systems for cluster environments. This is me. I have a PhD in computer engineering from CPUT, that's in Cape Town, South Africa. And in this session, I'll introduce the basics of file systems, then move into Linux file systems, and then finally explain how we use network file systems in cluster environments. Okay, let's start with the fundamentals. All computers store data in binary, which is this ones and zeros. And a file is simply a structured collection of data, right? So this can be an example of a file. Now, in Linux, everything is a file. Even important system resources are represented as files. This includes hardware devices, processors, communication sockets, and even directories or special types of files. This design makes Linux very consistent and powerful. Now that we understand the importance of files, let's discuss file systems. The system that manages how the OS or system interacts with files. Different file systems have different strengths. Consider performance features such as compression and encryption, which can affect speed and storage efficiency. Here are examples of Linux file systems. ext4 is used by Linux for its boot directory. XFS is another good one. Rocky uses it for its home and root directories by default. And ZFS is something you guys can look into. This is nice for multiple pools of NVMe's or SSDs. Mac OS usually has its own file system. I think it's called Apple file system, APFS, and in Windows uses NTFS. And then there's one that you guys might know, FAT32, that you'll usually use for flash drives. You can use flash drives in all different types of operating systems. Alright, I asked ChatGTP to generate a summary table for me. And it gave me this. I like this very much. And what I want us to have a look at is this sequential throughput versus random I/O. We can see XFS. This is the file systems that I decided to focus on. And I can see XFS is excellent with sequential throughput, and ZFS is just as nice. But when it comes to random I/O, ZFS is just much better than all the rest. Metadata performance, these two are quite similar. When it comes to parallel I/O, they are also quite similar. You can go through this table on your own, pause and go through the table if you like. But what I think the graph that really represents file system is this one. I like this. This shows ext4 as the old reliable, but XFS as the new faster one, and then you can think as ZFS as the Cybertruck of file systems. It's something new, something fancy that might outperform this one. All right. So this is some essential commands that we'll use when setting up a file system. You'll usually use lsblk. This is just for list block. So this will list all available storage devices, and then you can use fdisk to format anything that this thing shows you. It will show you if there's device SDA, SDB, whatever. That's why I just labeled it as SDX. So you can use sudo fdisk and whatever device to partition it. And once you have your partitions, if you took a block and partition it maybe into two pieces, one of them you can maybe set as ext4, so SDA1 maybe, and SDA2 you can maybe set as the other file systems that we had a look at. So this is how you format a specific partition to a specific file system. And then you can use the sudo mount command, mount -t, and then whatever type of file system it is, where it is, so it's in device SDA1 maybe, mounted to wherever your mounting point is. So take note of this command, because this command we'll use in our demo as well. All right. Sudo, for those that don't know, is just escalated or privileged user. So we're running this just as in with escalated privileges. Okay. So because we will be working with clusters, we will be working with multiple compute nodes. You can look at view as this image as this is you using your laptop to log into some cluster where you'll usually have a login node. So you log into your login node, and then you'll run jobs, and it will run all over your compute nodes. But as it's running, it will need its files in a central location. That's why we use a network file system. So you think about it, if one file is here and you need it there, and then it still has to communicate and all that. But if the files is just in a central location, anyone can just find it and work and share files using this method. But for beginners and for this competition, we recommend that you use your login node as your file server. So think of this as one machine where you log into this machine. It will be your file server as well. Send your jobs there, but it can get all the storage information there. Because we'll be working with a small cluster, this configuration should be fine, should be sufficient. Okay. This is essentially how a network file system works. It's usually a central server that exports a directory, and multiple clients mount that directory over the network, allowing them to access the shared data. Okay. And you can think of this as, let's say this is your login node, that will be your NFS server. And then all your compute nodes will be your clients. This data that's split, you can split it over multiple drives, and this multiple drives can even be on, this can be in one machine, multiple drives, but it can also be multiple drives across different nodes. It doesn't even have to be on one machine. It's just this thing manages and it knows how to pull the data, and then this is just, so it knows, oh, it's just one thing that it's connecting, but this thing does all the management. Okay. These are all the commands that we'll use throughout our demo. So I just wanted to quickly run through them, and then I'll do a little demo so that you guys have an idea of what's going on. So on our server, we'll sudo dnf install nf-utils. This is just our packet manager that's installing nfs-utils. nfs-utils will install all the nfs stuff that we need. We'll even install it on the client as well. So that's all we're installing, is just that. That's all you need. And then you can use some file editor, whatever you like. I used Nano on here, but you can use Vim or whatever you prefer. And then we'll edit etc exports. And we'll just add this line. I'll explain this line in a second. So all this line does is it takes what you are sharing, so your share, where it's located, so you put that first, and then your network that you're sharing with, and the slash of your network. And then this RW is just to tell that clients can read and write to this thing. Asynchronous is to tell it that this thing is asynchronous, you can write and read at the same time, so it just makes it faster. There's no subtree checking, so there's usually NFS will check, hey, does this belong to another tree and all that. None of that checking. And this no root squash just means that if the client is saving something as root, it's the same as the server working on that file as root. So if there's something on the server that's restricted to root, then if this client is root, it's the same root. But if that's not there, then you'll have to be on server as root if there's specific root files or permissions. Next command we'll do is sudo export fs minus ar. I think is for all, and the R is for rebuild. So it's rebuilding your exports, and then we'll enable using systemctl, enabling this NFS server. On the client, all we're doing is we're just sudo mounting again -t, but this time we're mounting NFS. We need the server. I said head node here. Head node's IP or name, if your names are set up in your host file. What you're sharing, this you'll be able to see here. What you're sharing and where you're mounting. It's the same as it's the same mount command. So this we can use on server to show us what are we exporting, and on the client we can use this command to see what has been mounted. Okay, so let's get to our demo. Let me show you guys what I set up. So on OpenStack I set up 3 nodes, a head node and two COM nodes, you will most probably work with something similar. Only thing I've done on here is nothing installed. It's I only set up SSH so I can jump between the nodes. Alright, so let me get to my trusty mobile extern, and then let us start. Right, here I am. If I check host name, I'm currently on my head node. So first thing we need to do is install. I did pre-install this so that we don't have to wait long. It's already installed. It says completed. Now the next thing I want to do is make something that I want to share. So I'm going to quickly just go to root. I'm going to have a little look. What we have, let me just ls minus all. I can see everything belongs to root. So there's no way that I can create something as the Rocky user that I can share over the network. So let me make something, make the, and I'm going to call it my share, because I think that's what we said in the tutorial. I think this is going to give me an error. Yes, I need permission. So I'm going to quickly force this sudo, and there we go. If I ls now, I can see there's my share, but the problem is my share belongs to root. So I won't be able, as Rocky, I won't be able to create anything in it. So I need to do it your own and give it to me and my group. And it's that. I think I'm going to get another error. Yes, because I need to be sudoing this. Okay. Let me just zoom in so you guys can see clearly. If I ls minus all now, I can see my share now belongs to Rocky, it belongs to me. So if I go into my share, which is on root, and I check it's empty, so let's just create a little file. Let's call it head.txt. We ls now. I just wanted to create this so that we can see on it. We created this on head node, and if we go to the COM nodes, once we mount this folder, we'll be able to see this file that we created. Alright, so the next step is, all we have to do is edit our exports. So it's sudo text editor exports, and then we can type that little command. Oopsie, I'm so sorry. And then we can edit that, type that command in. We just type it there. It's my share, it's my network, and all that stuff that we discussed earlier. Let me just save this, exit. And now I can enable my NFS. Enable now. I can check if it's running systemctl status of nfs minus server. And it's active and it's running perfect. And now I can use this one, the export NFA, or just so I can rebuild all my exports, and I can check if it's there. I can use the show mount command I said earlier, and it says unknown. Is because I just started the service up, so I quickly need to exit the shell and then just quickly reload it, and I'm back in, and then I can say show mount minus e. There we go. And I can see on this head node I'm exporting my share to that network. That's perfect. All right. So next, if I jump to my COM node, COM1, okay, I can just check host name just to make sure I'm there, but I can see I'm there on my COM1. Right, I'm there. So the first thing I need to do is install those tools. Once it's done, I can run the mount command, which is sudo mount minus type, it's nfs, and then I can see it's exporting on head, head's IP. That's fine. I know I already set this up. Okay, but let me use the IP. Let me just get head's IP. Let me exit here. And then network management CLI, and here's head's IP. It's 192.168.18, right? So if I go back to COM1, let's run the mount command now, which is this one. Okay. and that's the IP 192.168.0.18, and the file is that my share, and then where this doesn't exist yet, the mount.share. Okay, so let's create that. If I go to /mount, and if I have a look, yeah, there's nothing there. So that command would have given me an error. I can quickly run it to show you. I'll get an error that mount point doesn't exist. See here, mount point doesn't exist. So let's create the mount point. It's called share. I don't have permission, so I must sudo mk the share. If I have a look now, I can see the file is there. If I run that command now, it's mounted, and now I can use df -h, the fancy one I told you guys earlier, and I can see share is mounted there by mount.share. So if I go into share and I have a little look-see inside, I'll see there's that file that I created on head. So let's create a file. Let's make a new file, touch, call it com1.txt, where at least both files is there. If I exit, if I'm back on head node and I go to my share, and if I have a look-see, I can see there's that two files that got created. Alright, okay, perfect. Now I want to show you, let's make another share. Let's make it on our home folder. Alright, if I say print working directory, I can see I'm in home Rocky. Let's see what's in here. Is nothing. I'm just gonna make and I'm gonna call it share. And Alice, there I can see share. Now what I'll do is I'll go back to my exports. I'm on my head, so I'll go to exports, and now I can copy this thing as is. Copy this. Oopsie. Okay, I'm being lazy. Let me just type it out. But instead, that thing it's in home/Rocky, and it's called share with a small s. I want to export this to my network. So now you see, now I got two exports. I'm going to save this, exit, and I'm just going to rebuild my exports, rebuild them, and then I want to check show mount -e, and I can see I'm exporting that file and I'm a folder, and I'm exporting that directory as well. So let's go to my com2, and now I already installed nfs-utils, so I can just use the mount command. I can mount I think it's sudo mount, yeah, sudo mount. This time I'm going to use head. This because previously I used the IP, but now I want to use the name head, and it's called, I can see here it's called home Rocky share. So this whole nonsense, I have to type home Rocky share. Oh, and then where I'm going to mount it. Again, my mount point doesn't exist, but this time I want to mount it in my home folder. So in home Rocky, let's call it new. Doesn't exist, I know it doesn't exist, so mkdir, let's make it, and then remount it. And now I can touch in here with no issues, because this is in my home folder. There's no issues of owning and all that. So if I touch, I need to go into new, and if I say touch, let's call it com2.txt, and if I ls now, that file is here. This is on com2. If I exit, and now I'm on head again. If I ls, there's my share. If I go into share and I ls, I can see there's the files there. And as easy as that, that is how easy NFS is and how easy it is to set up a network file share. Thank you very much. Let me just go back to my slides and make sure there's nothing else. That's it. No, thank you very much. I hope you enjoyed it. Bye.